All right, function classes, we have started a new section of our unit. So we are going to do rational exponents. So go ahead and get this in your notes because this is what we're going to be doing. So we're going to start with doing exponential notation for nth roots. So this is, if the nth root of a is a real number, then you can rewrite it as a to the 1 over n. So you're going to see different notation. This was something that was difficult for me to learn as a student, and so when I was learning it, I remembered that that x to the 1/2 was always the square root of x, so then I could figure out what I needed to do. And that if you look, you can see the number on the bottom of the fraction matches the root. So the number right here, this bottom, is going to be your index. We just don't typically write it for the square root. So this is going to be an example. So if I'm going to evaluate this, I'm going to rewrite it so that I know that my index is 5, and then this whole thing is going to go underneath the radical sign. So I'm going to take the 5th root of 32, which we've already learned how to do. So if I do 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 2 is 32. So then I know 2 to the 5th power is 2, or 2 to the 5th power is 32, so then the 5th root has to be 2. So now how would I rewrite this? Again, my index is 2, so I'm going to take that and put that on the outside of my radical sign, and I'm going to find the square root of 64. So if you look, these numbers match. So if you look, this one matches here and here, this matches here and here. So then I would rewrite it as square root of 64, and I get 8. What about this one? Now this one's going to take it's going to take some of the rules we learned earlier and apply it to this one. So I am going to take just the 81 just under that. This negative is going to be like -1 times all of this. So I'm going to find the 4th root of 81, negative 4th root of 81, which means I'm going to evaluate the 81 and multiply that by -1. So remember, when we have this here, it's like saying -1 times 81 to the 1/4. So now we have something with parentheses. So if it has parentheses, that means it's going to stay with it. So that means this whole thing stays together. So that I'm going to find the 4th root of -81. So when there are no parentheses, or if it's on the outside of parentheses, it stays on the outside. If it's on the inside of the parentheses, then it's going to go all under the radical. Does that make sense? Yeah. Okay, good. All right. So if that doesn't make sense to you, please ask questions in class. So then the answer for this, because my index is an even number and this number right here is not in parentheses and it is a negative number, then I'm not going to have a real solution. So if you didn't know that and you didn't recognize that, make sure you get this in your notes. What I would expect to see and what Ms. Wadley expects to see from her for an answer for this would be no real solution. But this just tells you why. So now if we have looking at this, my index is going to be odd, and all of this is going to go underneath. So I'm going to find the cubed root of -64. Well, the cubed root of -64, so we're going to have a negative number, right? Because we need to get to one. This is going to be, so if we did -4, -4 times -4 is a +16. Positive 16 times -4 is a -64. So then we end up with -4. So you got to remember that when this is odd, then we can find any answer we want. So that goes with that absolute value stuff that we were learning. Now this one, how would we evaluate this? Well, now we're going to take the cubed root of 1 over 27. The whole thing. Everything that's inside the parentheses goes underneath the radical. Everything that's attached to the exponent goes underneath the radical. Sorry, a teacher came in and right when I was in the middle of that. Okay, so we're going to find the cubed root of 1 over 27. The way that I think about this is I break it up. I take the numerator and a denominator. When the whole thing is underneath that radical, we can actually rewrite it this way. Why isn't it working? There we go. We can rewrite it as the cube root of 1 over the cube root of 27. And that's the way I always do it, and then it doesn't seem as scary of a problem. Now I'm not thinking about, well, what is the cube root of 1 over 27? So if we do that, we get the cube root of 1 is 1, and the cube root of 27 is 3. So then that's it. All right, so now we're going to be talking about defining and using expressions in the form of a to the mn. So this is what I would put. So if m and n are positive integers, with m and n being in its lowest terms, meaning it's totally down to the simplest form. So if I gave you 2/4, it's actually saying 1/2. You would do it this way. So what I would say is the m represents the power, and the n represents the index or the root. So we already kind of learned that this tells us what root we're going to take. This just lets us know that we're going to take it to that power on the outside. So the whole thing is going to be in this whole root is going to be inside of parentheses, and then we're going to take it to that power. Now, if we ended up with something like this, let's say negative 16 to the 3/2. So if we have something like that, then we would rewrite that as negative 16, oops, I forgot the negative sign, negative 16, the square root of negative 16 cubed. So if we have that, I already know that this is an even index and this is negative, then I cannot evaluate that. So I need to write that so you can read it better. So negative 16. And we can't do that. All right, so we're going to do some examples. So make sure you get this in your notes. So 25 to the 3/2 is going to be rewritten as 25 to the 1/2 to the 3rd power, which is just the square root of 25 to the 3rd power. And the square root of 25 is 5. So now we have 5 on the inside. We're going to have 5 cubed. 5 cubed is 125. So let's do this one. Go ahead and get this in your notes. And how would we rewrite this? Well, we would rewrite it as 27 to the 1/3 squared, or to the 2nd power, because again, this tells me what's going to go in here, and this tells me what goes out here. So then I'm going to find the cubed root of 27 to the 2nd power, which is 3 squared, which is 9. So now this one's a little bit different. So this one's going to take some of those rules that we've already learned and add it to the rule that we're learning now. So the negative is on the outside with no parentheses. So this is saying negative 1 times 16 to the 3/2. So I'm going to keep that negative 1 on the outside. So I need to remember, now I'm going to find the square root of 16 cubed. Well, the square root of 16 is 4. The negative, look, the negative stays on the outside. So then the negative, so now what we're going to get is the square root of 16 is 4 cubed. 4 cubed is 64 times negative 1. So we have negative 1 still on the outside. We get negative 64. Because negative 4 times negative 4 is a positive 16. 16 times negative 4 is a negative 64. So now, so look, we have this, no parentheses. Now we have this on the inside of the parentheses. If it's on the inside of the parentheses, then that means the whole thing is our radicand. The whole thing goes underneath the radical sign. Okay, so I use brackets just to show you like bigger parentheses. You could just use, like if I were to write this, I would just use parentheses, but I wanted to show you that this whole thing is taken to the 1/3 power, and then we're squaring all of that. So we're really going to have the cubed root of negative 64. So again, so now I know I can evaluate this because my number is odd, and even though this is negative, I can, and I'm going to get negative 4, but negative 4 squared, look at, it's on the inside of the parentheses, What is negative 4 times negative 4? It's a positive 16. So this one kind of goes back and forth between the signs, so you have to be really, really careful. So this is a really good example to have in your notes. Here's another good example. So you're going to see both of these forms right here of the fraction, so be careful when you're reading. You're going to see this all the time. So this would be rewritten as the square root. So this one would be the square root of negative 36 taken to the third power, right? Well, what is the square root of negative 36? Well, that's not a real solution. So then it doesn't matter. We're going to get a not real solution cubed, so then we just get no real solution. So it's not a real number since negative 36 to the 1/2 power or the square root of negative 36 is not a real number. If you did not know that, make sure you get this in your notes. Okay, this is where we're going to stop. I will cover this rule on Monday, and then on Tuesday we will get some practice with this. Monday and Tuesday. All right, thank you guys so much. I hope you have a great weekend, and see you in class.